All right, so let's talk about law of cosines. So if I'm trying to find A, or let's talk about how A is related to A and the rest of this triangle. All right, so here's the formula. First I'm going to put little a, and I'm going to square it. Little a stands for what? The side of this triangle. Okay, this is, don't get confused, just bear with me, okay? At least through the first example. We're going to talk about the formulas, we're going to go through the first example, then you can ask questions, okay? So, when I'm doing this, I need to say, well, I want to find this side, so I'm going to square, and I'm going to square something else. Then I'm going to subtract 2, and I'm going to multiply all of that by the cosine of A. So draw that shell is what I want to call it, the shell. So, if I'm talking about A, what do you think I'm going to also be talking about? B. So I would square B, and I'm going to multiply B times the angle. I'm also going to square C, and I'm going to multiply C times the angle. All right, so that's for A. So let's do the same thing again. I'm going to square a side. It's going to be equal to squaring the other sides and adding them, then subtracting 2 times those other sides times cosine of the angle I want. It'll become more natural. I told you it was going to be a little bit challenging, right? But I think the way I'm doing it, setting it up, will help you. Okay, so that's the shell. You'll see. That's the shell. Let's fill in the shell. This time let's talk about B. So I'm looking for little b squared times, and that times the angle of C. So what am I missing? A and A, C and C. See how it's working so far? Let's do the last one. I'm going to square a side. That's going to be equal to squaring the other side and subtracting 2 times those sides times the angle of the side I want, or the angle that I want.
It doesn't matter which category you put them in, like you get rid of the
No, does not matter. So this would be C squared, because I'm looking for the cosine of C. Fill in my A and my A, and fill in my B and, oops, wrong color, B and B. So let's try the first example. You want me to go back? Yeah. Okay, so let's start on this one. Notice that yesterday we talked about the law of sines. The law of sines worked when you had the side that was across from an angle. Do you see any of sides that are across from the angles that we know? No, so we can't use the law of sines on this. That's why we're using the law of cosines. And you can see why the law of cosines is absolutely the last resort, because it's pretty involved, right? Okay, so I'm going to draw my shell. I'm gonna do it down here. I'm going to square something. That's going to be equal to the other squares minus 2 times the side times cosine. So it's saying find x. Where's x located? Opposite of the angle. X is right here. So I'm going to call that, let's put that in blue. I'm going to call that cosine of, actually, sorry about that. It shouldn't be cosine of x, it should be cosine of what? 45, because that's the angle. Where does x go then? Out in front. You guys okay so far? Cosine of 45. That's the angle that we know. Wait, what I say? No questions until after the first example's done, because I think a lot of you are going to understand what we're doing as soon as we get going. All right, so if I'm talking about this side, I also know this side, right? So I would put the 25 here and a 25 here. Then I'm going to put an 11 here and 11 here, because those are the other sides. So as I do that, and this is what I'm talking about when I'm going to go faster now, x squared equals 25 squared plus 11 squared is 746. Minus 2 times 25 times 11 is 550 times cosine 45. This should be treated as, this is one whole number right here. You guys see that? It's the two sides multiplied times the angle. So how do I solve when I have a square like that? Take the square root. So we're going to take the square root of this and take the square root of this. And I will get x is about, and this is where I get in my calculator and do the calculation. So the answer is 18.9. All right, so write this one down. Okay, so once again, let's draw our shell. We're going to square something. It's going to be equal to the sum of the other side squared minus 2 times the other side times cosine of the angle. It says find the measure of L. So I'm looking for this angle right here. I'm looking for L. But I don't know what it is. There's a hint right there. What are we going to use at the very end of this problem? The inverse of cosine. Because I'm looking for an angle. So I'm looking for big L. Therefore, I'm going to start with little l. What's little l? This is kind of hard to see. It'd be 24. All right, so we've got 24 taken care of, so all I got to do is worry about the other two sides. So I've got 5 that needs to be squared and multiplied, and 27 that needs to be squared and multiplied. A little easier now? Okay. All right, so I'm going to go a little bit fast on this one because I've got all these numbers written out to begin with. So I've got 576 minus 5 squared times 5 squared plus 27 squared is 754.
I don't think it's the cosine of L. It only be 24.
No, we don't know the angle.
Oh.
Minus 27 times 5 times 2 is 270 cosine L. I'm actually going to move this over a little bit. Put that right there. Give ourselves a little bit more room. I'm going to subtract 754 from both sides. That's going to give me negative 178 equals negative 270 cosine L. What's my next step? Divide by negative 270. Divide by negative 270. These cancel. Finally, I'm trying to find cosine of L, so I'm going to multiply both sides by the inverse of cosine. I'm going to put that in my calculator. You guys see why I'm doing cosine times the inverse of cosine, right? If you know your exponent rules, the cosine of 1 times the cosine of negative 1 equals the cosine of 0. They cancel each other out. Alright, so if we put all of this in our calculator, I'm going to do that now and come up with the answer. Okay, so we got 48 is about the angle of L. Make sense? All right, let's talk about this. Let me give you a second to write this down. Okay, so let's recap for the whole chapter. So right triangles are a little bit different. So what's the most comfortable way to solve a right triangle? Exactly. Pythagorean theorem. Okay, then we learned something about special triangles, right? Which is even faster than Pythagorean theorem if you remember it, right? If you have a 45, 45, 90, then you know the hypotenuse is larger by radical 2. If you have a 30, 60, 90, the hypotenuse is larger by 2. It's larger by 2. And then the larger leg is larger by root 3, right? So then we moved on to so, ka, toa. So all of this that we did, this whole chapter, has to do with right triangles. As soon as we move away from a right triangle and we talk about any other triangle, the first thing we did was the law of sines. But I think we've learned today that there's sometimes you can't use the law of sines because you don't know the opposite, right? So the last case scenario is law of cosine. Nope, you have to figure it out on your own. I have a really good example. This next one is really going to sum it up for you, okay? Okay, that's what the next example is all about. Okay, so let's look at this last example. It says determine whether the law of sines or the law of cosines should be used. Well, I can't use the law of sines because do I have a side opposite that angle? No, so I have to use the law of cosines. All right, so I know I have angle S. So I'm going to concentrate on side S. So let's write this out. We would have S squared, we should just write our shell, right, equals square of the other side plus square of that other side minus 2 times the sides times cosine of F, which is 1, whoops, my color didn't change. 145. I'm going to fill in the rest of my piece of information. I fill in 17 and 17, 32 and 32. Everybody with me so far? I've got these values already ready to go. Ready for them? F squared equals 1313 minus 1080 cosine 145.
You do that again, right?
Yeah, I'm that good, James. No, I come prepared. Okay, I know. I'm amazing, huh? No, I've never claimed to be amazing. I just say I'm resourceful. And I think being resourceful is even better than being amazing.
No.
Okay, guys, recording. Take the square root of each side, and when I do that, I get F is about, I'm going to put this in my calculator. If I put this in my calculator, I get 46.9. So this side is 46.9. Okay, let's go on to the next page with this piece of information. Now that I've got this piece of information, now what do I do? Law of sines. Right? Because now we have enough information to use the law of sines.
The law of sines doesn't have all three sides.
No, it has to have an opposite. So sine of 145 compared to 46.9 will be equal to sine of, let's see what I start with, D, compared to, what's the opposite side of D? 32. Cross multiply, 32 times the sine of 145 equals 46.9 times the sine of D. I'm looking for an angle, therefore at the very end I'm going to end up what? Inverse sine. Divide by 46.9, divide by 46.9. Those cancel. Multiply both sides by inverse sine, and I get inverse sine of 32 sine 145 divided by 46.9. All that in a calculator equals D. And it is, I heard it. Good job. 23. Too much. Finally, if this is 23, what's this? Angle E can be found by simply 180 minus 23 minus 145, 12. Good job. We're done.